So you did an activity yesterday. How much were you able to get done? How much were you able to get done?
I didn't make it to the third one. That's all.
That's fine. If you got, I didn't expect everyone to be able to make it to the. Look, when I leave an assignment, and I try to leave enough for you to keep me busy during the whole period. I don't want you running out of stuff to do and then just say, "Oh, Mendoza didn't leave stuff to do." You know, that's not right. I also remember this. We have 30 people in the class. Well, less than 30 really, but 30 people in the class. Let's say, of these 30 people, some people will be able to get it all done because they've had chemistry before in middle school or whatever, and some people would get one done. Does that make sense?
Yes.
It's okay. Whatever you got done is fine. As long as you were working all period long and you're working at your own pace. It's about you learning. It's not about getting something done. Does that make sense? If you're learning, if you got one activity done and you learn that activity well, that's good enough for me. If you got you got it all done and you understand it all, that's good enough for me. Like whatever it is, I want you, but here's what I don't want to happen. I don't want you to blow off all period talking nonsense and then getting half one done or working below your potential. Because working below your potential is going to get you a below your potential score. And I want you to have the highest score you can get on your OST. I want you to be as prepared as you can for the rest of your years in high school. I want you to be ready to go to college. That's my objective. Is that clear? To get you through your freshman year in high school with the skills you need to be successful. Period. Yeah, or should I say period?
Period.
Yeah. Yes. Yeah.
Unless you're trying to say it with a T.
I know, I'm just playing. I don't know. I mean, I don't know. That's the point. That's what's funny is an idiot doesn't know what's going on. That's the idiot being me. Yeah.
I forgot.
Okay. All right, so let's move on. And let's make sure we all understand what's going to happen on the test this Thursday, right? Because today is Tuesday. And on Tuesday, October 15th, right? And we have a test on Thursday. Now, yesterday you went over a lot of the stuff that's going to be on that test. I'm going to tell you what, a lot of that stuff in that activity is going to be on this test. All these activities. So if you want to continue working on your own, that's fine. Also, any extra credit will go on your grade before I put it in, before Friday, okay? So I'll have an assignment that says extra credit, Mendoza owes you or something like that.
Like you'll be after the test?
I don't know. I'm not sure. What? Oh, you just fill it in whenever you can. Put in whatever extra credit I owe you, okay? And I'll give you that. I have my notes, but I want to make sure I didn't make a mistake. Now, that's a test on Thursday, and your test is obviously on atomic structure. But I still haven't been able to get those colored periodic tables printed, but I will. It's 100. It's 100. I got to go get more ink. I started to do it, and then I had to get more ink. So that's all there is to that. So we're dealing with the atoms and molecules. You need to know what an atom is. Hopefully everyone knows now. It's a number of protons and electrons and neutrons. And the neutrons have 0 charge, electrons have -1, and protons have +1. So hopefully at this point you all know that. Hopefully you all know that what the word isotope means. So that's my hope. And that's same. Iso, by the way, just so we're all clear. Iso means same. Iso means same. ISO means same. You'll see ISO as a prefix in a lot of different things. It means same. Same number protons but different number of neutrons. Now, to be clear, when you're dealing with an isotope and the same number of protons but a different number of neutrons, and this is true of a lot of things in science. When I tell you a fact, the fact is important, but what's interesting is it has, like most facts, it has consequences. And it's the consequences that you really have to think about. So there's consequences. Do you know what a consequence is?
Yeah.
What is a consequence to you?
Getting punished for something that you
Okay, a lot of people use it as a word for punishment. That's correct. But it's not really about punishment. What does the word consequence mean? That's right. I like that better. It's an outcome because of some action or some reality. So you're in the hallway making noise. There's a consequence to that. Somebody's going to notice, somebody's going to complain, security's going to come, or the principal's going to come. So there's consequences to behavior. And a lot of people think of it as punishment because of it, because often it is. But it's not necessarily punishment. For instance, there's a consequence to you studying. What's the consequence for you studying?
better results on tests.
Better results on the test. So,
I was gonna say you get to know it.
yeah, you get to know it. Excellent. I like that. Yeah. So something happens. This is true. True. And because this is true, therefore, there's a consequence. Therefore, what? Because it's true, the mass is different. And to understand that, you have to understand everything we talked about, which is what? That mass is number of protons plus the number of neutrons. If the number of protons are the same, but the neutrons are different, then what? Then the mass is different. All right? If, then. This is true, therefore something else is true. And that allows us to test, and we know that that's a hypothesis, and that's the structure of the language that you're looking at. So because an isotope has different numbers of neutrons, because it's the same number of protons, it's the same element. So that's another consequence, right? So there's two consequences here. Because it's the same number of protons, it's the same element. But because it's a different number of neutrons, then you have the mass is different. Does that make sense to everybody? So there's two consequences from this one truth, all based on all the things that we've looked at up to this point. Because the same number of protons, it's the same element. So I can have carbon with a mass. We have carbon with a mass of 12, and I can have carbon with a mass of 14. But both carbons are going to have a proton number of 6. A proton number. Oh, that was horrible. And here the proton number. So the proton numbers are the same, and that's what makes them both carbon. Like, how can you have carbon, the same element with two different masses? Because the neutron numbers are different. So everybody should understand everything I just said. And it took us a couple weeks to get these definitions and drawing them and practice problems. But if you're not understanding that, you need to see me on Wednesday night, because Thursday's a test. Or get a tutor, go see a tutor after school, something. But you should understand that. All right? Any questions up to this point? If you have a question, you can ask now. Okay. So no questions. So now we've talked about chemical bonding, and we've looked at the fact that you can have carbon. If I look on the periodic table, I'm not going to pull it up again, but the periodic table looks something like this. Oops, that's opposite. Looks something like this. So you look on the periodic table, you'll find carbon is here, and somewhere on this side of the periodic table, and you'll notice this in group 4. It's actually, there's two ways of numbering it. It'll either say group 14 or group 4 in Roman numerals, usually Roman numerals, sometimes in numbers. This ones place is what you have to be looking at. The ones place is group 4. So I know I have 4 valence electrons. 1, 2, 3, 4. That's the outer electrons. There are more. There are 2 more, right? Because there's a total of 6 electrons. Because carbon has a positive. If it's neutral, I know if it's neutral, there are consequences of that. The atom being neutral means, therefore, then if I have 6 protons, I must have 6 electrons. So I have 6 electrons, but I only show 4 because that's what's on the outer shell. It needs 4 to have a full octet. Does that make sense? Well, carbon can do some really interesting things. Carbon can make bonds with other carbons, and it really makes it a very interesting molecule. In fact, it can even form rings with itself more than once. It can form, bonds with itself more than once. It could even form something called a ring. And it can form different kinds of rings. This forms a hexagon. So I'm going to number the carbons. 1, 2, 3, 4, 5, 6. And there's another interesting thing about sugars. We're talking about a sugar here, by the way, in case you're confused. And you are, I'm sure. Sugar. Sugars are not the only carbohydrates. There's sugar is just one example. The broader term is carbohydrate. You've heard of this? Carbs. A lot of people like to say. Carbo because of the what? Because of, look, carbo because of the carbon. There's a lot of carbon in carbohydrates. And hydrate because there's a lot of OHs. So there's a lot of, it's water. Water's going to be produced, water's going in, water's coming out. So it's a hydrate. So carbohydrates are mostly carbon, hydrogen, and oxygen. So do you see any of the other schnapps elements there? Remember, what are the elements of life? Schnapps.
Carbon, hydrogen, nitrogen, oxygen.
Phosphorus and sulfur. Excellent. Yeah. Hello. Who's that? Oh. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. CHO. CHO. Carbohydrate, those are the elements of life, but in carbohydrates, you're only dealing with mostly dealing with C, H, and O. Very specialized little group of elements. All the elements in the periodic table, these three make up all the thing that you call food is made of carbon, hydrogen, oxygen. Mostly. Now, there's another interesting thing about carbohydrates that you need to know. You need to know these because there are consequences to it. There are consequences that have implications beyond the fact. So this is a fact, but there are consequences to knowing that fact that you're going to have to answer. Are you texting on Teams or something? What's he doing? Are you taking notes? What do you?
Yes, this was just open.
Okay, because I just saw you moving. It looks like a text box. I'm sorry. It looks like a little texting box. Oh, your email. It's email. So it's texting, but email. Okay. I mean, I knew there was writing in a box. I knew that. I can see that much. I'm not crazy. Oh, at least not because of that. All right, so there's a ratio to carbohydrates. One carbon, when you have one carbon, you have two hydrogens, and you have one oxygen. A 1 to 2 to 1 ratio. Please pay attention. 1 to 2 to 1 ratio. That means for every one carbon, I have two hydrogens and one oxygen. So oxygen and carbon are 1 to 1, hydrogen and oxygen 1. By the way, if you take a look at the formula for water, as you all know, is H2O, two hydrogens and an oxygen. The formula for water is two hydrogens and oxygen. Note 2 to 1, two hydrogens and an oxygen. Hydrate, water, carbo, C. I'm helping put together some language here. I hope you get it so that when we move on, you don't get confused. So water is H2O, but do you see any carbon in water? No. Water is just oxygen and two hydrogens. And we're going to break water up next week and then build it up again. We're going to explode it in tiny little explosion. Don't expect a big one. It's going to be a pop. It's not going to be a boom. You don't want it to go boom. Trust me. I've worked with explosives most of my young life. You don't want it to go boom. No, you're just ignorant. I was the same way. I'm telling anybody who thinks you want to hear boom, because I'm telling you, I was the same way. That's why I became a tanker and a combat engineer, so I can blow things up, because I was your age. I wanted to hear booms and pop, 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 and boom, a boom, a boom. And I did it. And I can tell you right now, you don't want it. Ugly things happen when that happens. 1 to 2 to 1. So now let's look at so here's the carbon. Now I'm going to draw this out. Do I want you to draw it out every time? Do I want you to draw this out every time? I'd like you to draw it with me. But do I want you, I'm asking a question, so I'd like an answer. Do I want you to draw it out all the time? No, I don't. If you said yes, that's fine. You're just trying to get me to shut up. I get it. But no, I do not expect you to draw this out all the time. I just don't want you to draw it. I just don't want you to think it's going to be overwhelming, like you're going to have to draw this. You're not going to have to draw this. I'm just trying to show you the underlying, I'm trying to show you what's under the hood. I want you to drive the car, right? But I want you to understand what's underneath the hood when you're pushing the gas pedal, what's happening, so you don't think it's magic. There's actual reasons and consequences. So from the carbon, I'm going to try to use different colors here. I'm going to erase that arrow. So I'm going to try to use different colors. Now notice I numbered them. So if you think about how this is numbered, you're going to build these this week. You're going to build them using models starting tomorrow. So I'm going to expect you to build this, even though I'm not going to draw it again. So I would draw it because you're going to build it.
I drew them out.
Excellent. In your notes. So oxygen, if you notice, oxygen is like a zero, it looks like a zero. O looks like a zero, correct? That's why I put a line through my zeros. Because O looks like, girl, if you don't focus and look on this board and stop talking about whatever's going on, I do not care what it is. It does not matter. I appreciate you. If you're choking, I'm sorry. Someone will give you the Heimlich. Other than that, please pay attention to what's on the board. Thank you. So here we have carbon, right? I said one hydrogen and one oxygen per carbon. Notice there's an oxygen here. This is oxygen. It looks like a zero. And if you go right, you go to the right, what you're going to find is you'll number them 1, 2, 3, 4, 5, 6. So you're numbering them to the right and going around the circle. Does that make sense? 0, 1, 2, 3, 4, 5, 6. That's not a zero, that's an O, standing for oxygen. But you can look at it like a zero, and that way you can remember how they're numbered. I have AP biology kids that still don't remember how to number these. You start at 0 and you go around. All right, just clockwise, simple, easy peasy lemon squeezy. So now, to add the hydrogens and oxygens, what you got to do is you just have to I don't know why it does that once in a while, but it does. So you have an oxygen and then a hydrogen. This is every carbon, there's a carbon and a hydrogen. Because carbon needs how many bonds? How many bonds does carbon need? 4. You have it, right. If you didn't say 4 right away, you're not studying. 4. 1,000,000 times in the last week and a half. 4. Carbon makes 4. How many bonds does oxygen make? 2. If you look on the periodic table, oxygen is 2. It needs 2. Where's it? What? Once used to carbon can't make another bond. Do you see that? Carbon has 1, 2, 3, 4 on. See the 4 lines on the carbon? Carbon's full up. So oxygen has to bond to something else, and what it does, or have a charge. It can have a negative charge if it wants, but it doesn't want, right? So it bonds to hydrogen. And an update soon. All right, so you have this little group here is going to be an important group. You're going to see it a lot. We call it a functional group. The functional group is called, it's O and an H. Anytime you have an OH together, it's called a hydroxide. Hydroxide. So anytime you have an OH together, it's hydroxide. You'll see hydroxides everywhere in your cells. Your body's full of hydroxides. In fact, you drink them all the time as well. So these are very important little groups of elements, of atoms. It's a molecule. OH is a negative, it's an ion. So when you see an O and an H, just by OH by itself has a negative charge. So hydroxide has a negative charge. But of course, this hydroxide doesn't have a negative charge because it's bonded. Do you see that? Okay. So OH has a negative charge. So now let's go out and add the rest of these. There's an OH here, and actually they alternate, so let's go ahead and add OH here and H here, and here's an OH. And when I say OH, I mean an oxygen bonded to a hydrogen. Does that make sense?
Mm-hmm.
That's what I mean. I don't want you thinking, why do we put the O first? Because the oxygen is bonded to the carbon and the hydrogen. I hope that makes sense.
You said it again.
Which part?
The last part you just said.
We put O first because the oxygen is bonded to the carbon and the hydrogen. The one that can make the most number of bonds usually goes first. You want to group them together because hydrogen is bonded to oxygen. Nothing's going to bond to hydrogen because it's full. This oxygen can make one more bond. There it is. It's looking for something. Who's it going to bond to? Who's it going to bond to? We don't know. But it's going to bond to something. It's going to bond to something. In this case, it's bonded to carbon, but it can be bonded to anything. It can bond to another hydrogen and make water. We can do that. So here we have, again, alternate. Oh no, this one doesn't. This one just has a hydrogen. How do I know this one only has a hydrogen and no oxygen? Number 5. Why don't I put, everyone else has an OH on it. Why don't I put an OH on this one? That, love it. She learned and she knows the consequence. This has 4 bonds, and the consequence is it can't bond to anything else. Could it bond an oxygen? Yes, but see, it already has an oxygen. Where's its oxygen? Right here. It just made a circle because of the energy. It has things beyond this class. It would take another few months to explain it, but just know things exchange bonds all the time. We call that chemistry. That's what chemistry is. It's a look and study of how things change bonds. Yeah. Yeah. Now, that being said, up here, this last carbon has to have 3 things on it. So what do you think it has? It has an OH for sure, right? Because everybody else. So let's count them. Let's see how many oxygens we have. We have 6 carbons. How many oxygens do we expect? 6. Somebody said 6 and they're correct. Why do I expect 6? Because it's a 1 to 2 to 1 ratio. I expect 6 carbons. If I have 6 carbons, the consequence is I should have 6 oxygens. And also another consequence is I should have 12 hydrogens. That's what I should have. This is a way for you to check and see if everything's right. Here's carbon. 6. 1, 2, 3, 4, 5, 6. I should have 6 oxygens. 1, 2, 3, 4, 5. Where's the 6th? Up at the top. Isn't... Oh, no. Come on. Really? Oxygen, hydrogen. Now let's count. 1 to 2 to 1. That the number of oxygens you agree is right. So oxygen's good. Carbon's good. What about hydrogens? How many hydrogens do I expect? 12, correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need 2 more. And where are they? Well, it just so happens. So I need 2 more, but luckily, I think you can see carbon also needs 2 more, so we're good. So that is what sugar looks like. Because of this shape, because of this combination of atoms, that's what makes something sweet. When you taste sweetness, that's a chemical test. That's a chemical reaction that's happening on your tongue that sends a signal to your brain that says sweet. If it's not sweet, you don't have something that looks like. It doesn't just have to be this. It has to be some kind of carbohydrate, some kind of shape like this. We make a molecule called saccharin, another molecule called, there's a bunch of different ones. You call them non-sugar sweeteners, right? Non-carb sweeteners. They have the same shape. You just can't use them. So you trick your body. It tastes sweet, but you can't use it. This you can use for energy. You can use this to eat. we call this sugar. And the specific sugar, and you have to know this is a must know. You don't have to know how to draw this, but you do have to know what are the things you have to know. Let's go over that, because that's a good place to pause for a second. You certainly need to know schnapps, and most of you know it, because I've tested it. You certainly need to know carbohydrate. That doesn't mean you'll know for the test, because you have to keep practicing. Carbohydrate, you know that. You should know CHO and its ratio, right? You should know that. You should know hydroxide is OH. So that you should know. You should know that the sugar that's C6H12O6 with a six-sided ring. Do you see this is a six-sided ring? Can you imagine this being a ring? And can you imagine putting your finger through it? All right, so this is a ring, a six-sided ring, that you need to know that is something called glucose. You've heard of glucose, right? Everybody's heard of glucose. That's glucose. Six-sided ring, C6H12O6. I'm only going to ask you to know two different sugars. Glucose and another one called ribose. Ribose only has five carbons. So how many hydrogens does it have? 10. And how many oxygens? See how cool that is? If you learn the formula, you'll know all your answers because of consequences. So when we look at ribose, what we get is a five-sided ring. Do you have to know the shape? Do you have to know how to draw it? No, but I'm drawing it. Five-sided ring with the OHs and the Hs. Everything else is the same. Everything else is the same. It's just five-sided ring. So it's five-sided. A five carbon sugar with a five-sided ring. Now, I always debate whether to tell you the next thing or not, because it's really an AP biology point, but it's also something that you're going to hear. It's a sugar you hear about a lot. There's that really you should know what it is. So, and we make it out of corn from corn. It's in a lot of fruits, so we call it fructose. You've heard of fructose? You cannot digest fructose very well. Your liver has real issues with it. Over time, it can do some damage. So you don't want to eat a lot of fructose. Unfortunately, all the sugar you drink, a lot of it is fructose. It's high fructose corn syrup. Sugar is not sugar. They're not the same. They taste the same. In fact, fructose is what we call an isomer. Isomer. Iso being the same. Has the same number of carbons. It has the same formula, C6H12O6. It's very similar to glucose. The difference is it has a five-sided ring. It makes a five-sided ring. Even though it still has six carbons, because it does this. It looks like a little guy with his arms up, two little, like it's say, help me. So I'm not going to put the oxygens and hydrogens, but that's what fructose is, a five-sided carbon. You do not have to know fructose, but I thought that's an aside. If you want to know, if you know, you might ask, what is fructose? It's another one of these single ring sugars. These are called monomers. Is it time to go? My alarms are not on. I turned them off for yesterday. Sorry. These are monomers. That's it. That's what you need to know for today. Tomorrow we're going to put these together and make dimers and polymers. You've heard of polymer? Okay, well you will tomorrow. These are monomers. They're one of many. Think of a Lego kit. This is one Lego block. It's called a monomer. When you put a bunch of them together, we call it a polymer. Mono means one. Mono means one. So mono means one, but mer means unit. So this is one unit. And just like in a Lego block, if I switch this color palette to yellow for a second, because most of the ones I've seen here are yellow, right? If I take these little Lego blocks and I put them together, if I take a bunch of these and put them together, each one is a monomer. If I put them together, a bunch of them together, it has to be a bunch. If I put a bunch of these together, then this is called a polymer. And what does polymer mean? It means many. Poly means many. And mer means unit. Many units. So a monomer, we're going to take these and we're going to make them into polymers. Tomorrow, you're going to build this. You're going to build glucose. And then we'll put them together and we'll make a polymer. Okay? You're going to build them with little plastic models, not Legos, but like Legos in a way. All right, very good. Thank you for your time. I think you did a great job today for the most part. Have a good one.